Hello class, it's me, Mr. Harris. How you doing? Right now, in front of you, you should have a piece of paper and a pen. At the top of the piece of paper, write today's date. I don't know what it is. Alright, then under that, write this term, plate tectonics. Plate tectonics. That's what this slide is about. This PowerPoint is about plate tectonics. Hey, look at all this nonsense. So look, you can see some recognizable shapes in here. There's Africa, there's South America, there's North America. I don't know what that is, Europe or something, Asia maybe. Look how this stuff is all stuck together. That's weird, because this stuff isn't stuck together now. But one time it was. Why isn't it stuck together anymore? Plate tectonics. That's why. Alright, moving on. Plate tectonics are about the Earth's layers. So write down Earth's layers right there. Here we have, what I want you to do is write the names, these three names right here. The rocky crust, the outer mantle, and the inner mantle. Those are parts of the Earth's crust, which is the top layer of the Earth. It's kind of like if you think of the Earth as like an egg, the crust would be like the shell on the egg. Alright? The Earth's rocky outer crust solidified billions of years ago, soon after the Earth formed. So the crust is not a solid shell. It's broken up into huge, thick plates that drift atop the soft, underlying mantle. So the Earth is kind of like so if you think of the Earth as an egg with an egg shell, it's kind of like the shell isn't whole, the shell is broken, but it's still on the egg. So, moving on. Alright, the crust is the top layer. Well, or as this slide calls it, the outermost layer. It's 5 to 100 kilometers thick. It's made of oxygen, silicon, and aluminum. So that's where we're living now, on the crust. And here's the different parts of the crust. Got the continental crust, the oceanic crust. Alright, moving on. Then under that we've got the mantle. So the mantle is the layer of Earth between the crust and the core. It's where most of the Earth's mass is. It's got more magnesium and less aluminum and silicon than the crust. It's a lot denser than the crust too. So underneath the mantle is the core. So they believe it to be mostly iron, smaller amounts of nickel, almost no oxygen or silicon or aluminum or magnesium. Look at this, picture's pretty cool. Here, pause the video for a second. Just look at this. You got the crust, the upper mantle, the regular old mantle, then the outer core, and then the inner core. Look how far away the inner core is. 778 miles. How do they even know that? It's amazing. All right, moving on. Look, it looks like a gobstopper, doesn't it? Kind of. All right. Then you've got tectonic plates. So look at this map of the world here. So it shows you where all the continents are, right? You got your North America here, South America, Africa, Europe and Asia. There's India there, but they're all sitting on different plates. So those are like the broken chunks of eggshell. Okay? So which plate are we on right now? We are on the North American plate. Australia's got its own plate. And look at the Pacific Ocean. It's just a whole bunch of stuff in a plate. I like this one, Cocos plate, which is like a little guy. And there's this one, the Juan de Fuca plate. He's just a little guy. So there's various different sizes, okay, of tectonic plates. Alright, so plate tectonics. So it comes from the Greek word tectonikos. And they're pieces of the lithosphere, which is like the top layer of the crust, that move around. So each one has a name. They fit together, kind of like jigsaw puzzles, but not like a super good jigsaw puzzle, like kind of a jigsaw puzzle that maybe you made at home. And they float on top of the mantle, similar to ice cubes in a bowl of water. All right, then we've got continental drift. All right, so check this out, you guys. This GIF shows the continents moving around over millions of years. So even right now, the continents are moving. We just can't feel it because it's happening so slowly. So look at it. Here's where we are right now, North America. There we are. There's Chicago. Okay, whoa, but we started out down here. The U.S., our whole continent is just cruising around. Everything is cruising around. So in the beginning, there was one continent. It was a supercontinent. All the land was stuck together, and it was called Pangea. It was about 245 million years ago. And Pangea split into different continents, Laurasia and Gondwana. It's about 180 million years ago. I don't know, this GIF doesn't show it very well. It's splitting into Laurasia and Gondwana. Alright, and here's some biological evidence of Pangea. Just that there were, like, this guy right here, the Synthognathus, lived in South America and Africa, and scientists are like, they'll be finding fossils of this guy over here and over here and over here in Africa, and they're like, what? How could it live in two totally different places, separated with a huge ocean in the middle? Did these dudes have boats or something, and they just sailed between one place and the other? No, obviously not, because there's some kind of lizard. Lizards don't have boats. So, scientists have theorized that what happened was that South America and Africa were actually stuck together at one point. And I mean, if you look at it, they line up so beautifully. Look at that. It's weird, isn't it? Likewise with this guy, this thing. Fossils of this fern, man. You got it in Australia, you got it in Antarctica, you got it in India, whatever that is, Madagascar, Africa, South America. It was everywhere. All those places are very far away from each other now. All right, now this shows how plates move. It's kind of cool. I like this drawing over here. It shows like the boiling water. So yeah, the heat comes up, boils, but then it causes swirls over there. Swirl there, swirl there. So then the plate will be sticking on top, standing on top, and you know what would happen to those plates? They'll move around. They'll rub against each other and things like that. They'll kind of cruise around the top of the bowl. All right. So it's hot. It's hot down the center of the earth, and it's like boiling stuff. Check this out. Divergent boundary between these Arabian and African plates. So look, this plate is like, I'm going to go over here. Well, this Arabian plate's like, I'm going to go over here. So what's going to happen to the Red Sea eventually? Is the Red Sea going to get smaller or bigger? All right, write down these notes. All right, and then you've got this convergent boundary, Indian and Eurasian plates. So this Indian plate's like, I'm going to go this way, and the Eurasian plate's like, I'm going to go this way. Then they crash into each other. So what is right here? Does anybody know what is right here? It's called the Himalayan Mountains, and those are the biggest mountains in the world, the Himalayas. There they are, because the plates are like pushing into each other, and they're pushing up the mountains as a result. Pretty cool, huh? Then you got this boundary here. Look at that. Got this boundary of a plate. Look at that. Oh my God, it goes right through California. The Pacific plate, the North American plate. There's even a picture of it right there. You can actually see it. They're smashing into each other. That's why they've got so many earthquakes in California. Look at that. It goes right by San Francisco like that. It's terrible. All right. Pacific plate, North American plate, rubbing into each other. All right, now let's review this. Do this for homework. Name the 3 main layers of the Earth. Write what a tectonic plate was. Write what Pangea was. And then write what causes earthquakes. I'm going to check to see if you have these notes tomorrow. That'll be about 5 points. Then I'm going to give you a quick little assessment just to make sure you watched this video and took notes. Enjoy yourselves. I love you. See you in class.